When you're finding the values of trig functions, given the information about an angle, whether it's problem type 1, 2, or 3, you need to be familiar with these trig ratios. Okay? So cosine, sine, and tangent of an angle, these are your basic trig functions. Okay, and you need to be able to recall these ratios in relation to those functions. So what I did when I was learning how to do this was I just remembered that, okay, since C comes before S and X comes before Y, then the cosine goes with X and sine goes with Y. Okay, so I remembered that cosine of an angle is my X value over my R value. My sine of my angle is equal to my Y value over my R value. And then tangent, I remembered this one because it's like slope. And slope is the change of Y over the change of X. So tangent is your Y over your X value. And then once I remembered that, then I remembered what the reciprocal functions for each of these things were. Now, cosine's reciprocal does not start with C, so it's secant. Secant of theta is the reciprocal of cosine, so cosine's x over r, so secant is r over x. Sine's reciprocal starts with a C, and it's not cotangent. Cotangent goes with tangent, those kind of go together, right? Cosine, so sine and cosecant are reciprocals. So if sine is y over r, cosecant is its reciprocal, r over y. Okay, so cotangent's reciprocal is, since tangent's y over x, cotangent's x over y. Okay, so basically I'm gonna give you, in problem type 1, they're gonna give you a point. And if you draw a line to that point, that's called the terminal side of your angle. So here's an example of an angle theta, and here's the terminal side, and then you draw what we call a reference triangle that goes down to your, or up if it's in quadrant 3 or 4, to the x-axis. Okay, so here's my angle of theta, here's my value here. This point here tells you your x and your y value. So I'm going to show you what I mean by that. Okay, if you have something in a different quadrant, you can see here's my angle theta. This is what we call a reference angle when we draw this triangle here. We have our x, y, and our r value. If you notice, r is always the hypotenuse of this reference triangle that I'm going to draw. Okay, so let me give you some specific examples so you can see what I'm talking about here. So in this first example, I'm asked to find cotangent of theta, cosine of theta, and cosecant of theta, given the point -8, -3, and that point is a point on the terminal side of theta. Okay, so I always start these by just drawing a quick triangle. Just draw a sketch. -8, -3, it's going to be a -8, -3, doesn't need to be real technical. Okay, so that looks like it could be -8, -3. And I'm going to draw a triangle here. Let's go ahead and change this color here. Oops. Okay, pretend like that was like better drawing than I just did. Okay, so this is my triangle. And this value is a -8, -3. Which means my x-coordinate here is a -8, and my y-coordinate here is a -3. In this case, we're going to think of the negatives kind of as a direction. It's given us some information about the direction. Here, this is my angle theta, and here is my reference angle. So when you're reading about reference angles, this is what they're talking about. Okay, so you're asked to find the cotangent of theta. Now, in order to find the cotangent of theta, tangent is y over x, so cotangent is x over y. And I already have x over y, so I can just find x over y. I can find this one without doing any calculations. So my x value is a -8, and my y value is a -3. And so I just need to simplify it. Okay, and so that's going to simplify to 8 over 3. And that's what cotangent of theta is going to equal. Okay, now to find the cosine of theta, cosine is x over r. So I need to calculate what r is. And so you can always calculate any of the missing pieces for this reference triangle by using the quadratic formula. Excuse me. This is not the quadratic formula. It's the Pythagorean theorem. Okay, so then we're going to replace the x here with the negative 8 and the y with the negative 3. And we're going to solve this for r. R, by the way, is always going to be a positive value. So here, negative 8 squared, that's 64, plus 3 squared is 9. And so that's going to be 73. And then we're going to square root both sides here. So when we square root both sides, we get plus or minus the square root of 73. But remember, r will always be a positive value. We're just going to talk about the distance for r and not use that as any kind of location. That's how it makes sense in my brain anyway. Okay? So now I've got x and I know what r is, so I'm going to replace these in here. X is a negative 8 over r, which is the square root of 73. Now, a lot of times you could be finished, but we want to rationalize our denominator. And what that means is you don't want to leave your answer with the square root in the denominator. It makes it harder to calculate other answers and to compare it to other values. So what we're going to do is we're going to multiply this by the square root of 73, whatever's in the square root. And that's going to allow us to get rid of the square root out of the denominator. Okay? So then we can just multiply the negative 8 times the square root of 73, and that gives you a negative 8 square root of 73, over square root of 73 times the square root of 73 gives you the square root of 73 squared, and that will undo each other and leaves you just with the 73. They will undo each other. Okay, and so this is going to be my cosine of theta. All right, so you have one more value to calculate, and that's cosecant of theta. And cosecant is the reciprocal of sine. So sine is y over r, so cosecant is r over y. Okay, so r is the square root of 73, and y is a negative 3. Now you can go ahead and, I'm going to write this right here below. I'm going to pull out the negative out in front and just call that a negative square root of 73 over 3. And that's what cosecant of theta equals. Now let's look at one more example. Now again, remember, we're going to start by drawing our xy axis and plotting sketching a point 2, negative 3. So x is a positive 2 and y is going to be a negative 3. It's going to look something like this. Let's go ahead and sketch a little reference triangle. So we draw a line to that point, and then we draw a triangle that goes to the x-axis here. So here's our reference triangle here. So our x value was 2, our y value is a negative 3. We know we're going to need to find r, so let's just go ahead and do that first. So this is going to be 2 squared plus a negative 3 squared equals r squared. So this is going to give me 4 plus 9, which is 13. So 13 equals r squared. We square root both sides. We get plus or minus the square root of 13, but we know r is going to be positive. So r is the square root of 13. We can even put this over here if you'd like. Okay, so let's look at the values that we need to find. One of the first things we need to find is the cosecant of theta. Cosecant is the reciprocal of sine. Sine is y over r. So cosecant is r over y. Okay, so r was the square root of 13, and y was a negative 3. So I'm going to just go ahead and pull that negative out in front of that fraction. So cosecant of theta is a negative square root of 13 over 3. Okay, then let's calculate sine of theta. Now sine of theta is reciprocal of cosecant, so it's just simply, y over r. So it's going to be this reciprocal. So that's a negative 3 over the square root of 13. Now, remember that we need to go ahead and multiply this by the square root that we have in the denominator so that we do not have a square root in the denominator for our answer. Okay, so this is we're going to multiply the top parts together, negative 3 square root of 13 over square root of 13 times square root of 13, square root of 169, which is 13. And that's sine of theta. And then the last thing you need to calculate is tangent of theta. Now tangent of theta is like slope, so that's y over x. So my y value here was a negative 3, and my x value was 2, so that's a negative 3 over 2. And that's just what my tangent of theta is going to be. Now for problem types 2 and 3, this is going to be a similar process, just a few variations.